Hi everyone! In this lecture I'm going to talk about the effects of acid rain. And it is true that in our country we have seen a reduction in acid rain. Though globally, in especially developing countries, there has not been this drop in acid rain. And partially the drop again is from our Clean Air Act. But we still do see acid rain in our country. So keep that in mind. We still do see it, and it still is a problem. And so let's go ahead and talk about it. Here is a map of the United States and the acid deposition. Notice that the majority of the acid deposition is on the East Coast. And you can see that all these red dots here are coal burning power and industrial plants. And on the West Coast, or everywhere else basically, there's not very many of these coal burning plants. And so there is a direct correlation between acid in deposition, which could be snow or water or dry even. Okay, all of that is still dangerous. It's mainly due to coal. And if we look at what it can do to, for example, architecture, when the acid either could be dry deposition, where the SO2 molecule can actually just deposit itself onto the statue, or it can react in the air. But if it's dry, it will, when it rains, it will react at that time. And what we have found in this first picture is in 1908 to 1968, and there's a large difference in this molecule. This is just limestone, and it was just being dissolved away. It's like calcium carbonate being dissolved away. It also rusts metal, which is important for a lot of our structures. Even the Eiffel Tower, which is iron, can rust in acid. And the other one that's interesting is acidified lakes. So when you look at an acidified lake, people often describe it as being very beautiful, very clean, very clear. You get this really nice reflection on the water. And what that means is the lake is just really clean, like it's been cleaned by the acid. And it's so clean that all the life is dead. The fish, the algae, everything. And so these acidified lakes are really unfortunate, actually. And the only time where you're seeing where you have acid rain and you don't get the acidified lakes is where you have a limestone bedrock, because a limestone actually neutralizes the acid. And so in Sweden, when they were getting a lot of their lakes becoming acidified from the acid rain, they started actually putting limestone into their lakes to try to help lessen the effects. The other thing you can see is how acid deposition affects plants and soil. So what happens, you get your acid deposition either from rain or snow or again dry, and it comes down, and it can either leave direct damage to the leaves and bark just by burning them, or it can just where did it go? Or it can actually do something where it starts to leach the nutrients out of the soil, and that would actually weaken the plant itself, and it can also release toxic metal ions. And all of that can cause root damage, which reduces the nutrient and water uptake, which will eventually kill the tree. And it can make the tree more susceptible to diseases, to cold, to insects, to drought. And in places where there's still a significant amount of coal burning, such as Germany, they're really great. Germany's about 80% renewable energy right now, but they do burn coal still, and they do burn one of the dirtiest forms of coal. And they're seeing about 50% of their black forest is being destroyed by acid rain. And you can see that in the picture right here. And something I want you to consider is, why would all this be worse at the top of a mountain? And what we're seeing is that it's the rain shadow. A lot of that it's just the rain. A lot of that rain occurs at the top of the mountain, or the snow. And so then the worst of it's occurring there, and then there's more of the runoff you get later down. And in terms of animals, eggs need calcium, so you see a reduction in the bird population. When the acid fills the lakes, aluminum is actually leached out, and that's toxic to the fish. So the fish could die. They also could get acid shock, and they could die from that. And so it's especially the aquatic creatures are most sensitive. And we're sensitive to acid rain itself. And our examples is not just acid rain, but acid fog. And acid fog is actually more acidic than even acid rain. And this is just an example from our air pollution chapter, where we had the killer smog episodes. And again, these were just sulfurous smogs. That means the smog was filled with sulfur. And again, just remember, this was not insignificant. In 1952, there was about 4,000 deaths. All right, well, those were a few examples of how acid deposition, that includes rain and snow and dry deposition, and also how acid fog have effects on our environment and our health. And in reality, acid deposition is really air pollution, mainly from fossil fuel burning, and some of it from agriculture. And so the question for you is, what can we do different in our future? What can we do to stop these horrible effects? Can we find some other way of farming or some other source of energy? And that is partially up to us as the new generation coming forward to try to solve this. Okay, I'll see you guys next time.